What if I told you that the laptop sitting on your desk right now is about to become an ancient relic? On June 1st, 2026, at Computex in Taipei, NVIDIA CEO Jensen Huang did not just announce a new processor. He effectively announced the end of the traditional personal computer era. For 40 years, the relationship between humans and computers was defined by a simple mechanic: click and type. We used software as a static tool. But NVIDIA's newly unveiled RTX Spark superchip, codename GB10, completely smashes that paradigm. NVIDIA is literally squeezing the full architectural power, the massive bandwidth, and the brute force of a trillion-dollar cloud AI server directly into a 14mm thin laptop. This isn't an incremental upgrade. This is a total, aggressive reformatting of consumer hardware. If you think NVIDIA was content with just dominating the enterprise data center market, you missed the bigger picture. Jensen Huang is coming for your desk, and he has brought an unstoppable empire with him. Welcome back to the channel. Today, we are breaking down the terrifying engineering behind the RTX Spark, the secret master alliance NVIDIA built to destroy Intel and AMD, which industries are facing immediate liquidation, and why the tech world will never be the same again. To understand why the RTX Spark is such a massive shockwave, we have to look at the massive anxiety currently gripping the technology sector. Right now, the world is facing what we call AI fatigue. Tech giants have spent hundreds of billions of dollars buying enterprise GPU microchips like the H100 and B200 to build massive data centers. Investors are aggressively asking, where is the return on investment? Where are the actual products? Jensen Huang's answer to Wall Street is local agentic computing. Up until now, when you used an AI tool like ChatGPT or Claude, your computer acted as nothing more than a dumb terminal. Your prompt was sent over the internet to a massive, energy-hungry server farm owned by Microsoft or Google, processed there, and sent back. This model is expensive, laggy, and a nightmare for data privacy. The RTX Spark changes the game by moving the entire AI factory onto your local device. We are transitioning from centralized cloud computation to absolute edge dominance. Your next PC will not just run programs. It will host an army of autonomous AI agents working for you 24/7, completely offline. Let's talk about the pure, unadulterated engineering of this silicon monster. The RTX Spark is built on the exact same GB10 silicon wafer that NVIDIA previously utilized for its $4,699 DGX Spark professional enterprise workstation. Think about that for a second. This is not a downgraded mobile chip. It is server-grade architecture shrunk down via TSMC's ultra-advanced 3nm manufacturing process. Under the hood, NVIDIA has combined an ARM-based 20-core Grace CPU with a cutting-edge Blackwell architecture RTX GPU. These two powerhouses do not communicate through a standard, slow PCIe lane. Instead, they are physically fused together using NVIDIA's proprietary NVLink C2C interconnect technology. This allows the CPU and GPU to pass data back and forth at lightning speeds, while dynamically scaling system power from single-digit watts during idle tasks all the way up to a roaring 80 watts under maximum computing stress. It delivers an unprecedented 1 petaflop of local computing power. To put that in perspective, that is 1 quadrillion floating-point operations per second, packed into a device that weighs less than 3 pounds. But specs mean nothing without addressing the single greatest bottleneck in modern computing: memory allocation. If you have ever tried to run an open-source large language model locally on a standard premium consumer graphics card, you have undoubtedly run into the dreaded OOM error: out of memory. Traditional consumer GPU microchips are strictly choked by 8, 12, or at best, 16 gigabytes of dedicated VRAM. Once your AI model exceeds that size, your system crashes or slows down to a painful crawl. Jensen Huang's ultimate masterstroke with the RTX Spark is the introduction of up to 128 gigabytes of ultra-fast LPDDR5X unified memory. By utilizing a custom-designed, proprietary memory controller, the system delivers a staggering 300 gigabytes per second of raw memory bandwidth. Because the memory pool is completely unified, the entire 128 gigabytes can be dynamically allocated as GPU VRAM. This completely obliterates the memory barrier. For the very first time in human history, an independent software developer, a researcher, or a student can run a massive, top-tier 120 billion parameter LLM locally, while feeding it an incredible 1 million token context window completely offline. Now, history has shown us that having the best hardware does not guarantee victory. Just look at how long Qualcomm and Microsoft have struggled to make Windows on ARM a mainstream reality due to severe software incompatibilities. Jensen Huang understood this perfectly, which is why he didn't just build a chip. He engineered a massive, unprecedented corporate alliance to force the entire tech industry onto his platform. First, NVIDIA partnered deeply with MediaTek. MediaTek acted as the shadow engineer, contributing their elite, industry-leading mobile low-power architecture and power management systems to ensure this hardware monster could actually achieve all-day battery life in a thin chassis. Second, Microsoft CEO Satya Nadella personally took the stage to announce that the 40-year-old Wintel alliance between Windows and Intel is effectively dead. Microsoft spent 3 years secretly re-architecting the foundational security primitives of the Windows operating system to launch NVIDIA OpenShell. OpenShell is a native, deep system runtime environment built specifically to let local AI agents control your computer safely. To cap it all off, creative software titan Adobe announced they have completely rebuilt the core rendering engines of Photoshop, Premiere Pro, and After Effects from the ground up, unlocking a massive 2x performance leap tailored directly to the RTX Spark hardware pipeline. Let's address the elephant in the room: application compatibility. Historically, ARM-based computers were mocked by gamers and hardcore power users because they couldn't run legacy x86 software or multiplayer games. The biggest culprit was competitive online gaming anti-cheat software, which operates at the kernel level of the operating system and completely refused to function on ARM chips. Jensen Huang used NVIDIA's absolute monopoly leverage in the gaming world to solve this overnight. NVIDIA brought together Epic Games' Easy Anti-Cheat, BattleEye, and Denuvo. These anti-cheat giants officially announced native, hardware-level support for Windows on ARM. Consequently, global phenomenon titles like League of Legends, Valorant, and PlayerUnknown's Battlegrounds will run flawlessly and securely on the RTX Spark from day one. For legacy enterprise applications that haven't been natively recompiled yet, NVIDIA worked closely with Microsoft to optimize the Prism emulation layer. This means your legacy business software, specialized database tools, and old code bases will run smoothly with near-zero performance degradation, turning a historic weakness into a validated strength. With this level of hardware and software integration, the RTX Spark is a heat-seeking missile aimed directly at several multi-billion-dollar industries. The most immediate casualty is the premium laptop market currently dominated by Intel Core Ultra and AMD Ryzen processors. Global computer manufacturers like Dell, ASUS, Lenovo, Hewlett-Packard, and MSI have already abandoned exclusivity, showcasing flagship devices powered by NVIDIA Silicon. The traditional, heavy, loud gaming laptops and expensive creator workstations are facing systemic obsolescence. Next, look at independent software engineering and content creation. Coders can now locally host elite, multi-billion parameter code generation models to review, debug, and write massive code bases entirely in a coffee shop without internet, keeping proprietary corporate source code completely safe. Digital artists and 3D animators can render massive 90-gigabyte open-world scenes locally on battery power, eliminating the need for expensive desktop render farms. Finally, high-privacy, highly regulated sectors like corporate finance, international law, and healthcare can now fully embrace advanced AI automation. They no longer have to fear strict compliance violations because their sensitive customer data never leaves the local physical device. However, as powerful as NVIDIA's new empire is, it is crucial to realize that this chip will not conquer the entire world overnight. There are massive sectors that are completely immune to this disruption. First is the massive, high-volume, low-end budget market. The RTX Spark is a premium, high-cost product meant for computers retailing well above $1,500. Corporate office fleets, school computer labs, and budget consumer Chromebooks have absolutely no need for a 1 petaflop AI factory. These cost-sensitive segments will remain safely in the hands of cheap x86 processors or entry-level Qualcomm chips for years to come. Second, pure cloud-based SaaS platforms like Google Workspace, Salesforce, or online project management tools are totally unaffected. Their computational heavy lifting happens entirely in distant cloud data centers, making the local processing power of your laptop irrelevant. Lastly, we have Apple's walled garden. Apple's Silicon M-series chips have established an incredibly loyal, ironclad ecosystem among creative professionals. A hardcore Mac user who relies on Final Cut Pro and thrives within the Apple ecosystem is highly unlikely to cross over to a Windows-based laptop, no matter how impressive NVIDIA's hardware specifications look on paper. If you step back and look at the chessboard, you will realize that personal computers are just a single stepping stone in Jensen Huang's grand design. NVIDIA is executing an aggressive, multi-front strategy to establish absolute computing dominance across the entire physical world. Look at the automotive industry. The exact same hardware architecture powering the RTX Spark has been deployed into the automotive market through the MediaTek NVIDIA Dimensity Auto CX1 platform. This chip turns next-generation smart vehicles into mobile AI data centers, allowing cars to process complex autonomous driving algorithms and conversational multimodal AI agents locally without requiring a cellular network connection. Furthermore, NVIDIA's alliance with MediaTek opens the door for an aggressive, impending invasion into the smartphone market. Industry insiders widely expect NVIDIA to begin licensing its premier GeForce and RTX GPU intellectual property, complete with dedicated tensor cores, directly into future flagship smartphone chips. Jensen Huang's ultimate master plan is now clear. He is creating a unified computing codebase. From a 100,000-car data center cloud factory down to a smart vehicle, a 3-pound laptop, and eventually the smartphone in your pocket, the entire digital architecture of humanity is being systematically reformatted to run on NVIDIA CUDA. Thank you for watching this deep dive into NVIDIA's historic hardware expansion. Before we close, please note our standard channel disclaimers. The content presented in this video is strictly for informational, educational, and entertainment purposes only. It does not under any circumstances constitute financial, investment, legal, or professional marketing advice. Always conduct your own rigorous independent research or consult with a licensed professional advisor before making any financial commitments or stock market investments. Additionally, please be advised that all data, specifications, corporate partnerships, and product timelines outlined in this presentation are based entirely on the latest publicly available technology disclosures as of June 26. This video is completely independently produced by our channel team and has not been sponsored, endorsed, reviewed, or approved by NVIDIA Corporation, MediaTek, Microsoft, or any of their corporate affiliates. What are your thoughts on NVIDIA's massive push into consumer laptops? Let me know in the comments section below, and I will see you in the next analysis.